In this example, we have that an engineer models the sound wave output, the acoustic signature of a new submarine propeller. Now, the power output, P of F, in decimals is as a function of the sound frequency F in hundreds of hertz, and is given by this polynomial F, P of F. Sorry about that, P of F. Now, engineers are looking for a frequency null, which is a frequency F where the power output is 0. So in other words, where P of F is equal to 0. Now, if F equals 1 is one of those places, we want to find the remaining two zeros of this polynomial. So I'm doing a lot of paraphrasing here. So we know that P of 1 is going to be one of the places that make this equal to 0. And our objective is to find the other F values where P is going to be 0 as well. So using this answer of 1 and synthetic division, we're going to divide our polynomial so we can create a quadratic. So 1, 1, negative 10, negative 10, 26, and 0. Now, I don't think factorization is going to work here because we have x squared minus 10x plus 26. And we're going to try to set this equal to 0. And I don't think any factors of 26 is going to give me 10 because we need this x, this to be negative, and this to be negative as well. No combination of factors of 26 are going to give me 10. The only options we have are 1 and 26, which obviously 1 and 26 are not going to give us 10. So that option is out. And the only other factors of 26 are 2 and 13, and that doesn't give us 10. That would give us again, that doesn't give us 10. No combination, right? So that's out. So that means that factorization is not an option. So our only option, again, is the quadratic formula. So this is the only option that we have to solving this equation. So what we're going to do is get the fact that we have the values of A here, B, and C. That's 1, negative 10, and 26. And like I mentioned, use our quadratic formula. So we have negative B, which is negative 10, our plus and minus, our B value, again, negative 10 to the second power this time, minus 4 times the value of A and the value of C. We're going to divide that by 2 times the value of A, and let's see what we get. So we get a positive 10, obviously, a positive 2 down there, and a negative 4 inside the square root. So since I ended up with a negative, you should end up again also with a negative value there. So again, when you do the synthetic division, you should end up with a quadratic that is not factorable. So go straight into your polynomial, into your quadratic formula. And then this value right there is going to be a negative value. Now we can evaluate this if we want to on decimals. You don't need to. But as long as I have on my decimals calculator, I have this enabled, the complex mode enabled. Normally by default it's set as turned off. I will turn it on, and then I can take the square root of any negative number, like negative 4, and it tells me my solution is going to be 2i. So 2i here, okay? So x equals 10 plus or minus 2i divided by 2, which, since both of those numbers are divisible by 2, 10 is divisible by 2, so that's going to be 5 plus or minus, and 2i is divisible by 2, which is 1i. Oh, no. 1i here. So 1i, this right there would be the answer. Now, if you don't want to do all of that and don't want to simplify that, you do have to get rid of the negative sign, and you do have to at least simplify like this, where you get rid of the negative sign inside the square roots, and you have to write it as 10 plus I times the square root of 2, and then 10 minus I times the square root of 4 divided by 2. So you don't have to actually get the actual value of this. You could just, at minimum, you have to get rid of the negative inside the square root by putting an I on the outside. And again, it doesn't matter whether you put it in the front or you put it back here. It just has to be on the outside. But there are your other two values.